This lesson is going to be all about estimating and multiplying multi-digit decimal numbers. Last week we were adding and subtracting decimal numbers, and this week we're going to multiply. Now you've multiplied multi-digit numbers before, but multiplying decimal numbers may be new. So let's get into this. First, I'd like you to take a look at this do now, and without a calculator, use estimation to identify whether A or B is the correct answer. So pause the video, try this do now, and then we'll see how you did. All right, let's see how this goes. So number one, I have 12 times 31. So if I were to estimate this, 12 is kind of close to 10, and 10 times 31 or 30 is close to 300. So I have an answer that's 37.2, an answer that's 372. Clearly my answer is in the 300 realm. So B is the correct answer for number one. All right, number two. I have 12 times 3.1. So that's kind of like 3 times 12 is 36. Again, my answers are 37.2 and 372, and the 37.2 is much more in the range of my estimate. So the answer here is 372, or A. All right, number three. We have 1.2 and 3.1. This is going to be a small number, right? Because this is 3, this is close to 1, so 3 times 1 is 3. So my answers are in the 37 range or the 3.72 range. And the 3.72 is much more in the range of my estimate. So the answer is B for number 3. And then number 4, we have 120 and 3.1. And again, that's like 3 times 120, which is like 360, so it's a pretty big number. So I'm comparing 372 and 37.2. This is much more in the range of my estimate. So the answer to number 4 is A. So we're going to do this again and then see if we can find a pattern that is going to help us when we multiply decimals. So let's take a look at some more problems. Again, we're going to use estimation to place the decimal point this time in each of these answers. So the digits for all of these answers are 384, but where the decimal goes depends on how big our number is. So let's take a look at the first one. 32 times 12, again, that's kind of like 10 and 30. When I multiply those, I get 300. So 384, I can't put the decimal point here. 3.84 is too small. 38.4 is too small. But 384 is much more in line with my estimate. So we're going to put that decimal point at the end. And if you want, you can put a 0 after that, but you don't have to. All right, let's take a look at the next one. We have 3.2 times 12. 3 times 12 is kind of like 36. So let's put the decimal point so that gives us an answer in that range. Again, I can't put it here because 384 is too big. Can't put it here because 3.84 is too small. But if I put it here, that gives me 38.4, and that's much more in my range of my estimate. So we can put the decimal point between the 8 and the 4. Let me write that out over here. All right, let's take a look at the next one. We have 32 times 1.2. Again, that answer is going to be in your 30 range. So I need to put my decimal point so that my answer is correct. So again, I need that to be in the 30 range, so I'm going to put my decimal point between the 8 and the 4 again. And finally, we have 3.2 times 1.2, and again, that answer is pretty small. So If I put the decimal here, that's 38.4, that's too big. But if I put the decimal point here, that's 3.84, which is much more in line with my estimate. So I can put my decimal between the 3 and the 8. So we've used this to see if we can find a pattern between our factors that we're multiplying and our answer. So do you see a pattern that could help you with this task? So pause the video for a little bit and think about what this pattern might be, and then we will come back and see if you come up with something. Alright, let's see if you came up with what I came up with. So here's the key idea. The total number of digits to the right of the decimal point in your factors is the same as the total number of digits to the right of the decimal point in your product. Let me say this again. The total number of digits to the right of the decimal point in your factors, each one of them, is the same as the total number of digits to the right of the decimal point in your product. So let's practice this, and then we're going to use estimation to make sure we have the right answer. So let's take a look at number 1. Here's how you apply this. In number 1, I have 1 digit to the right of the first factor and 2 digits to the right of the second factor. I'm going to underline those for you. There's 1 digit and 2 digits. That means my answer, I have to put the decimal point so there is a total of 3 digits to the right of the decimal point. So that means my decimal point is going to go between the 0 and the 7. Because now I have 3 digits to the right of that decimal point. So let me write that large, more large. 20.735. Okay, let's take a look at number 2. Here I have 1 digit to the right. Here I have 3 digits to the right. So I need to have 4 digits to the right of my answer. So that means my decimal point has to go between the 0 and the 2 here. Right, so that I have that 4 digits. And again, if I write that bigger, that's going to be 10.2652. All right, and then number 3, I have 2 digits to the right, 2 more digits to the right of that number. Therefore, I need to have a total of 4 digits to the right of my product. So that's going to put my decimal point between the 7 and the 6. So I have 4 digits to the right. So that's how you apply the key idea. Now I'd like you to try that on these next 4 problems. So pause the video for a moment, place the decimal point in the right place according to our rule, and then come back and restart the video and we'll see how you did. Alright, here come the answers. This first one, I need to put the decimal so there's 3 digits to the right. The next one I need to put it so there are 2 digits to the right. The third one I need to put so that there are 2 digits to the right. And then lastly, I need to write it so that there are, again, 2 digits to the right. However, I'm tricking you on this one, because note that that digit to the right on the first factor is 0. It doesn't count. So we only really have 1 digit to the right. So the actual answer to this one, the decimal point goes between the 8 and the 2. So did I trick you on that one? And here's where estimation is so important, because if I look at my estimate, I have 10 times 90. That's going to be around 900. So if I put the decimal between the 2 and the 8, I'm going to have 92.8, which doesn't make any sense. So having the answer be closer to 928.2 makes more sense with my estimate. So, rely on that estimate to help you make sure your answer is correct. Okay, so we've been figuring out where to place a decimal when we multiply two numbers. How do we actually put this into practice to multiply some numbers? So here's the key idea. In order to multiply decimals, pretend that the decimal is not there, and multiply them like whole numbers. Then place the decimal according to the rule that we just learned. You can then check your answer, of course, through estimation. So again, in order to multiply decimals, you pretend the decimal is not there and multiply them like whole numbers, then place the decimal according to our rule. You can check your answer through estimation. So let's take a look at this first problem. So we're multiplying 20.6 times 3.7. I'm always going to write the longer number on top. So that's going to give me 206. And again, I'm ignoring the decimal. On the bottom I have 3 and 7. So let's go ahead and multiply this. 7 times 6 is 42. That's the 4. 7 times 0 is 7. That's 0 plus the 4. And then 7 times 2 is 4. Alright, so in my next row I'll put a 0. And I have 3 times 6 is 18. There's a 1. 3 times 0 is 0. Plus the 1 is 1. And 3 times 7 is 8. And then of course I add these together. And right to left. The digits of my answer are 7, 6, 2, 2. So where does this come? Alright, let's take a look at the next example. Maria ran at a rate of 3.4 miles per hour for 6.8 hours. How many miles did she run? So for every hour she runs 3.4, so that's about 500 hours. The book is the same number of digits, so it doesn't really matter. 3, 4, 10, so I have 8 times 4 is 32. 8 times 2 is 24. That's why I was back to 72. So 6 times 4 is 24. 6 times 2 is 18. Digits of that answer Where does the decimal point go? Again, does that answer make sense? Basically, 3 7, so 3 plus 7 is 7, that range. All right. What I'd like you to do now is okay, I hope you did well on that. Now I'd like you to take a look at this word problem, and again I'd like you to pause the video and try this and then come back and see how this goes. So go ahead and do that and come back and check out what the answer is. Alright, check out the answer and the work, and hopefully you also got $47.76. And check out the sentence that I wrote as well. Keep it simple, just give some context. We know that Ben spent this much money on the goldfish. Alright, I'd like you to do one final problem to make sure you have this down. So go ahead and try this one. Pause the video for a moment, do the work, and then come back and check to see how you did. So check out the answer for this. You should have gotten 36. Statement of packet area, $36.05 for the day. Now this part doesn't really make sense. So there's nothing in the number. There only these 2 decimals. So technically, Alright, so I hope you did well with this. What I want you to do next is there are more practice problems with this packet. Go ahead and do those problems, and if you finish those, you can get started on the homework, and let me know if you have any questions.